Hello, everyone. I'm happy to see all of you joining us for the webinar from manual modeling to automation. I'm going to be your host for today, and this is a little about myself. So I am Modestas, a solution specialist of Be.𝗦𝗺 portfolio and certified Revit professional. Here you can see the housekeeping rules on the slide, and feel free to ask your questions and they will be answered right after the presentation. The recording will be available immediately and you will receive an email with more resources after the webinar. Today on the agenda, we have a brief introduction of Arcan's Concrete Collection demonstration and live Q&A session. So Arcans is a leading partner for digitalization in ISC and manufacturing industries. We are the first Autodesk Global Platinum partner with unmatched global reach and expertise. Arcans brings together a global team of experts. We offer more than just software. Our services including training, consulting, setup, and custom solutions to help you get the most out of your technology. And during this webinar, we will have some polling questions that will appear on the screen. So please share your answers with us. And now, what is Concrete Collection? So I'm happy to present a tool set that delivers results with efficiency, quality, and cost savings while maintaining team collaboration on projects of any size. The Concrete Collection combines reinforcement and modeling tools to streamline workflows on concrete structure projects. You will also have access to the Core Collection, creating a comprehensive toolkit for all your project needs. And now let's take a look. What are the modeling challenges that Concrete Collection solves? And one of them is inefficient methods for panel splits and detail placement, which leads to productivity loss. Manual rebar placement is tedious and leads to major time loss, and updates and modifications can significantly increase the risk of error. So now let's jump to Revit and see how we can tackle those issues using Concrete Collection. So first of all, let's get familiar with the tools that Concrete Collection consists of. So we have Smart Walls tool that can help you to split your panels precisely and accurately according to the distances that you set up that may be required by logistical solutions or manufacturing capabilities. The other tool is Smart Connections. I would say this is a unique tool for you to have to create from simple to complex rules on how the elements and what kind of elements should be placed on your elements in Revit at all. That can be, they can be hosted on floors, roofs, walls, any other elements. Also, we have floor panel layout. As the name itself suggests, it can help you to automate the splitting of floor panels into the concrete ones and into concrete panels for you. Now let's jump to reinforcement tools. So we have wall, beam, and column reinforcement. Those are powerful tools where once again you can create configurations from simple to complex rules on what kind of a rebars, how they should be placed, how the openings, windows, doors, or maybe some additional offsets should be made. So you can always easily configure these things in there. And the best part is that those configurations can be saved up in a shared server location and later on reused with you and your team members on any other projects that you might have. And to finish it off, we have Smart Documentation tool, which can help you to finish your projects. So with drawings, automate dimensions, tags, and maybe you need to number all the elements. You can easily do that with some settings that you can preset. So now let's take a look how all of them works and do a little bit of a comparison between Arcan's Be.𝗦𝗺 tools and Revit native features. So to begin with, I have modeled these walls like this, and I want to split them in certain distances, horizontally and vertically. For that, I can use split element or split with gap. And I might be able to do horizontal splits more or less accurate. However, when I'm working with the vertical splits, the first challenge of the day comes into play, right? I'm not sure if I'm making those splits in the right positions. So it requires me to put in additional effort to create additional views. That view should contain some reference planes with some offsets to find the proper exact locations where the split should happen. So it requires additional effort and additional stress to split those walls in the precise locations with precise distances. However, if I'm going to use smart walls of Concrete Collection, I can easily use split wall menu, and I can choose different ways how the walls can be split. I can split them by grids, by reference planes, by the openings, by distance from start or maximum spacing. Or horizontally, I can split them by levels, distances, and reference planes. So in this case, I don't need any additional views, any reference planes. I'm going to select these two walls, and I'm going to split them by levels. I can select references, and I'm sure that these walls have been split according to the levels I created in this project. Now I'm going to do the same thing for the vertical splits. I'm going to select these walls and split selected from start. So in a matter of moments, all those panels have been split according to the predefined distances set up in the smart wall settings. So they would fit into logistical solutions, equipment, or manufacturing capabilities that I have, right? So if I were to select this wall, I can see that it's not exceeding 2.5 meters. Same thing applies here. And maybe this wall is a little bit shorter. And here we can see the exact same result over here. So you can see how quickly it is to work with smart walls, to split them up to the result that you want to have. Now, once the walls are split, another important thing is to place the details, place the connectors, anchor points, some loops or connecting elements between the wall panels. And that's also a time-heavy task for you to do if you are using Revit only itself, right? So if I want to place multiple different elements on the panel, firstly, I need to find the element I want to use, right? So in this case, I'm using Project Browser, and I know that I have some lifting points under the structural connections categories. And I can start placing them on face of the wall panel. But as you can see, I'm once again ending up in the same situation where I lack precision and accuracy. So placing these elements using this particular view is not an efficient method. And that means that I would need to create additional view. And in fact, I do have one. And in that view, I would need to place some reference planes, something like this, one horizontal and one vertical. Then I will need to move those reference planes in the correct distance. And now I can finally place that element in the right spot. And the snapping itself of the element is also can get tricky, and you can place that element misaligned. And that would lead to potential errors. Now I place this element properly. I can go ahead and mirror this element to the other side of the panel. Let's do that. So now two elements are placed properly. I'm gonna copy this one as well to the center of the wall panel, something like that maybe, and move it downwards to the reference plane. So I placed three of those elements precisely now, but it took a lot of stress and a lot of effort from me to get them placed in the right positions. And unfortunately, I cannot go and easily copy these elements to the other wall panel, because if some wall panels are longer or shorter, if there are some cutout, geometrical changes, right, these elements would not automatically adapt, leading me to going panel by panel and manually adjusting the positions to make all the elements placed properly. And now I'm going to use smart connections for the same purposes. I'm going to select multiple walls over here, and I'm going to hit insert elements, and I can choose a configuration that I want to use. You can have multiple of those configurations for different scenarios, for different elements, and you can easily place all these details just like that. So let's do it over here as well. Maybe let's use different configuration now, as it is a connected wall. So in different circumstances, you can use different rules. Let's do the same thing over here. And let's also place the elements for the rest of the walls. And as you can see, I'm placing way more elements, way more quicker than if I were to place them up using Revit native features. And I can always be sure about the precision. And the best part of it is all of these elements placed are adaptable to the geometry, meaning that if I have longer or shorter walls, if they are opening somewhere, everything will be adaptable to those distances that you predefine in the configurations. So now I can actually select one panel. We can inspect how it looks like. So we have cut over here, 2 cuts over here. We have some holes placed in there for the lifting points. And we can also take a look at all the connecting elements between the wall panels. So we have those loops placed over here. We have these loops between the wall panels and even L connection loop over here as well. And when I mentioned you about the adaptability, for example, I can select this element, move it a little bit to the side, something like this. And now this bottom tube is not in the right position. So if I were to use Revit, I would need to manually go ahead and move that element and maybe once again create additional view for that. But in this case, I'm going to update the elements, and that tube will find its place back. So as you can see, how much time it can save for you when you're placing these details and you have a lot of them. So it's way more easier to just set up the configuration and apply them for all your elements that you have in Revit. So once we are happy with the result, with all the placement of details, let's take a look at the reinforcement. And reinforcement itself is a bit tricky by using Revit native workflows, as it also requires additional views. And once again, you will need to manually copy them, adjust them for each panel. So let's take a look at that as well, actually. So I have some additional views: reinforcement front section, side section, top view, and let's open up this 3D view. Maybe let's split them up like that. So I have 3D view, side section, and front view over here, and top view over here. So the first step is to go to the structure and select rebar. Now you have to choose a rebar shape, and I'm going to start things off using horizontal rebars using U shape. This is the one that I'm looking for. And then you change the diameter, maybe something like this, and then you can start placing that element. But as you can see, we already have an issue here where I have to manually adjust the length of the segments, right? So maybe this one is too long, so I'm manually overriding that distance. From the front section, I can see that I placed only one element, so I need to change that to maximum spacing, type in the spacing like this. Now I'm about to add horizontal straight bars. So let's look for the straight bar shape, change the diameter, and let's change the layout to the maximum spacing once again, and place it something like this. Of course, you would need to look if there are no intersection happening, adjust the constraints, adjust the offsets over there to get the proper result. Now I'm going to select this one and mirror it to the other side of the wall using the snap overrides, just like that. And let's place vertical rebars. And I'm going to be Yeah, now change the placement orientation to perpendicular to cover. One here, and maybe one here. And as you can see, I already made a mistake. I'll need to adjust the positions manually, and that can lead to additional efforts to get the correct result that you want to have, right? And the other thing, it took me quite a while to get the reinforcement placed. How about the other panels that they have around it, right? I cannot go ahead and easily copy these reinforcement to this panel as it contains a different geometry, openings. So once again, I would need manually to go ahead and override those reinforcements, change the constraints, add additional elements till I finally get the result I'm looking for. So let's compare that to Be.𝗦𝗺 Concrete Collection on how the reinforcement can be done with that. So let's go back to the previous view. And in this case, I'm going to use wall reinforcement. I'm going to select those two panels, for example, and let's hit create rebar. So I'm using the same configuration, even though the wall panels are different, right? One has opening, another doesn't. I'm not creating any additional views, nothing, just straight from the view that I have over here, and I got this result. And I can be sure about the precision and accuracy. I have the opening reinforcement bars placed properly over here. I have some U-shapes at the top and bottom of the wall panel. I have those opening U-shapes from the sides, and all of that is being done automatically for me. So I can create one configuration and reuse them. Doesn't matter if there are some geometrical changes or not. And the best part is the adaptability, right? So for example, now I'm going to do some modifications and changes in this project. I'm going to copy this window maybe somewhere over here, and I'm going to delete this one. So the reinforcement needs some adjustments over here to finally get along with the new geometry, right? And if I were to go with the manual workflow, it would take quite some time for me to get everything properly set up. And if there would be more than 1 or 2 or 3 panels, it would be a time-consuming task for me. But in this case, I'm going to select those 2 panels, update the rebar, and just in a matter of moments, everything will be sorted out for me automatically. So it reduces immense amount of stress for the engineer, for the drafter, for the modeler to get the results they want to have. And I also want to emphasize that with the Concrete Collection, you also get some tools from the Core Collection. And in this case, I'm going to show you the cut opening tool, whereas if you're using MEP link projects or MEP elements in your current project, you can easily go ahead and place the openings for those walls. Because if I were to select this wall and manually add those openings, right, it's not an easy task, where most likely I will need once again to get additional view to make a proper opening over here, maybe some reference planes to get certain offsets I want to have. And that can be easily configured using cut opening, where you hit insert openings, find clashes, and insert opening. And all of that will be taken care of by cut opening tool for you. So you can set up the thicknesses, you can set up the openings, the offsets, and all of that will be done automatically for you. As you can see, we have those openings created precisely. And now I can continue on placing reinforcement for them. So I'm going to select this wall, hit create rebar. Even though this is a different type of wall, I'm still using the exact same configuration. And we can see that the opening was successfully reinforced. The whole wall was successfully reinforced, actually. So it is seamless and efficient workflow for you to get a reinforcement done using Be.𝗦𝗺 Concrete Collection. So we went through the modeling phase, and now let's take a look what can be done in the documentation. So now let's see what the key challenges are for the documentation phase. So one of them is numbering. Can be a slow and error-prone process. as you have a lot of elements in the Revit project, and you need to go to manually type in the values for the mark parameters. The dimensioning and tagging can significantly extend the drafting time, and creation of drawings requires extensive care, double checks, which leads to inefficient workflows. Of course, there are way more challenges that arose during creating your drawings, the documentation using Revit native features, but those are the ones that I thought are the main ones. So now let's jump to the Revit and let's see how we can work with that using Concrete Collection. So prior to creating the assemblies, you will need to place in the mark values for all the elements you want to have, right? So in Revit, I can open up some schedules: wall schedule, beam schedule, and column schedule. And maybe let's once again split the view like this. So mark parameters are empty at this moment. And if you would be using Revit itself, right? So you would manually go ahead and type in the mark values that you want to see. And if there are some additional elements later on appears in the project, you need to go ahead and double check if all the values are up to date, if all the elements are properly set up, right? Which can lead to a potential human error or some misalignments with the documentation that you want to have. But in this case, I'm going to use smart documentation within the Concrete Collection, and it has numbering and tagging rules over here. And I'm going to activate the batch numbering. In 3 categories, in this case, you can add even more. You can set up different rules. I'm going to number the walls, structural columns, and framing all at once. So I have all these mark values placed up for me according to the predefined rules. So for example, all the walls have been numbered according to the level it is based on, the function, for example, exterior, interior, fundamental wall, and the number assigned to it. And if there are some additional elements appearing in the project somewhere along the line, you can easily go ahead and redo the process, renumber all of them. As you saw, it took only a few seconds to get the result done for you. So it's really a seamless way for you to take care of all the data management using numbering and tagging, right? And I'm using the sample configuration here. You can create your own ways. You can create your own rules how these mark values should be created according to your own standards or company's requirements. So as I am good with all the data in my elements, I can now continue on creating assemblies. But once again, let's do a bit of a comparison. If I were to create assembly with views of a specific panel, beam, column, or whatever other element, I'll need to select all the elements I want to see in that assembly, right? And once again, I'm ending up in a situation where I cannot be sure about the precision, because even now I selected all these elements that they want to create assembly of, and I see that I have 4 elements selected from the panel that is beneath it, meaning that I would get some elements that should not be in there. So, and if I have a lot of other elements surrounding that panel, in this case, it would be extremely hard for me to get a correct result. So once you selected all the elements, just like that, you can go ahead and use Create Assembly. Then you select the category, you can type in the name, and only now you can create views. But for the views creation, you have only the names and the view templates. And if I hit OK, I don't get any dimensions, any tags automatically. I would still need to fine-tune the whole drawing to get to the exact result I'm looking for. So in this case, I will need to use dimension lines. And if I have multiple of views in the assembly and multiple of assemblies in the project, you can imagine yourself how time-consuming task that is, how much stress that puts on the shoulders of engineer, modeler, drafter, right? And let's do a bit of a comparison now. I'm going to disassemble it. And I'm going to select the panel, only the panel, not all the elements, just the panel. Go to Assembly Views and use Create Assembly. Then you can select the configuration, because once again, you can have multiple different configurations, maybe for different set of elements. For the precast walls, let's hit OK. And in the matter of moments, Smart Documentation will create an assembly for me with all the templates assigned, with all the dimensioning over there, all the tagging, even the schedules, legends, or images can be also be placed in there. And the best part, that all of these views will be automatically placed on the drawing. So basically, I create assembly, and I get fully completed drawing for me. So we created an assembly for level 3 exterior wall, number 4. Let's look at the project browser. This is the one I'm looking for. Those blue marks identifies that all these views have been automatically placed on a drawing already. So let's jump straight away to the formwork. And we can see we have elevation created with dimensions and node parameters over here. What dimension is measuring over here, right? We have elevation top view. We have a front view. Once again, we can see all dimensions needed over here, text notes, and the schedules as well. Embed objects, material takeoffs, and QR codes. We can also take a look at the rebar drawing. So we have a rebar 3D view, rebar top view. We see all the dimensions, no parameters over here, front view, and rebar left view. And for the rebar list, we need to do images. So let's create rebar images. Basically, you create all the reinforcement in the project, then you go with create rebar images, and all the rebar will inherit the parameter of their own image. And the best part, that you can see the segment length on it as well. Also, that can be set up in the schedule as well, and the quantities over here. This is not something that you could easily do with Revit itself, right? And I want to emphasize that the whole setup, the whole view, all the views that you see here can be different. You can add additional views, additional schedules. You can change the view templates, dimension types. You can create your own kind of a standard, how you want the drawing to look like at the end of the day, right? So we basically modeled the wall, placed all the details on it. We numbered all the walls, right? We created a documentation in just a matter of minutes, basically. And now let's actually see how everything would work with the beams and columns. And I'm going to share some tips with you as well. So first of all, let's change the view to the beams and columns. And to begin with, I'm going to use smart connections, right? Previously, you saw me selecting particular elements and using particular configurations for those elements. In this case, I'm going to select all of them at once and use auto insert. So now our software will read information about the type parameters, and it will assign the configuration according to them. So basically, you can create multiple elements from different categories, but just change some type parameters, type in the name of the configuration, and you can use auto insert. So in a matter of moments, all the elements for different type of elements will be placed. So we can say we have corbels, we have lifting points, we have column shoes, we have anchor bolts, and once again, all these elements are adaptive to the geometry of the column, of the beam, etc. Right? And if I were to change the height, change the position of this beam, the corbel would automatically also adapt by using the update elements of smart connections. Now let's add some reinforcement. So let's use beam and column. For the time being, I'm gonna create reinforcement only for 2 columns over here. As we can see, they are different one. This one contains only 1 corbel. This one has 2 of them, but both of them have been successfully reinforced. You have 3 segments of reinforcement, and of course, you can change that. You can set up the way you'd like it to be. All the corbel elements also have been reinforced. The same applies over here as well. And so you can be sure about the precision and accuracy. And now let's do the same thing for the beam. We have L-shaped beam, we have T-shaped beam, and we have rectangular beam over here. So 3 different types of beams. but all of them we're going to get the reinforcement precisely placed using just one click, basically. And the software done the hard work for me in a blink of an eye. And once again, everything is customizable. Let's take a look at the T-shaped beam over here. Everything is properly reinforced. So now I can continue on creating the assemblies. So let's do smart documentation, assembly views. I'm going to select this beam, or this column, sorry. And let's create assembly. Now instead of precast walls configuration, I'm going to use column configuration. And let's hit OK. So once again, in a matter of moments, all the views will be placed with all dimensions in there for me automatically. So ideally, I could have all the elements reinforced. I could select all of them, all of those beams, and create the assemblies all at once. And let's do the same thing for the beam as well. Create assembly. And let's use different configuration now. The beam. And we're going to inspect the result in a matter of moments. So with this workflow, you can see how quickly you can get from A to Z, from manual modeling to the full automation of your workflows. How much stress and time can save it up for you. And it is seamless. It's easy to work with that. You can see a few clicks and I'm getting the results done. So now let's take a look at those drawings. So I have column level 1, number 1. Let's see somewhere over here. So once again, I have elevation views with dimensions of specified elements in the dimension node parameters. The corbels are being dimensioned to, elevation top views. All the information needed is there. Embed objects, material takeoffs, even the QR code, right? Let's take a look at the rebar. And I want to share one thing with you. So for example, I can use dimension lines to dimension the rebars, or I can use multi-rebar annotations with our tool as well. This is a recent update to our tool to have different approaches if there's a need for you to do that. And let's finish it off with the rebar list. So smart documentation, images, and create rebar images. So all this schedule will be filled in with all the information, making it easy to read with these images that has the length of the segment placed in there with all the quantities. And let's inspect the beam drawing as well. Once again, we see multi-rebar annotations, or we can go with dimension lines like this. And in this case, we see the rebar list already created. So we went from the very beginning of the project to the documentation phase in just a matter of minutes. As you can see by yourself how easy it is to work with our software. You can share those configurations with your team members, so it's flexible for you to use it in all the projects that you have. So I want to thank all of you to joining into this webinar, and we're going to contact you, and thank you all for being with us today.